For 18 months, we have been in reactive mode. Pundits had predicted an event such as the pandemic, but it is fair to say that no one was prepared for the magnitude of its impact. Back in 2017, Nokia Bell Labs had forecast that IP traffic would more than double in the next 5 years. But little did we know how reality would strike. Indeed, our network analytic tools have shown that in the past 12 months, network traffic has grown 60%, 7 times the predicted pace. Enabling society and the world of work to continue functioning during the pandemic is one important role of networks. But digitalization, supported and driven by Nokia's customers, plays a role in countering other important global challenges too. Chief among these is climate change. In April 2021, Nokia reaffirmed our commitment to sustainability across our own operations and from our own products, to reduce emissions by 50% between 2019 and 2030. We're improving energy efficiency by ensuring efficient power consumption despite increasing bandwidth capacities, by designing equipment for reuse, and by working with more environmentally friendly materials. We take back excess or obsolete products, refurbish and resell equipment, and dispose of end-of-life products responsibly, avoiding up to 40% of the carbon dioxide emissions of the manufacturing process. Telecoms networks are, in short, becoming increasingly important across a range of urgent global challenges. But the more society and business rely on them, the more we see attacks being launched against them. Distributed denial of service traffic is now the fastest growing category of traffic on the internet, outstripping video by a massive 40%. This is a serious problem for service providers already challenged with delivering consistently high service qualities to satisfy Industry 4.0, 5G, and other critical applications. The disruptive impact of surging DDoS traffic cannot be understated. At the same time, service providers are embracing third-party transport options, open architectures, and globalization. These moves are made for sound technology and commercial reasons, but they can make IP networks and the data that flows through them more vulnerable to attack. Service providers looking to secure new revenue from the digitalization of critical industries must be confident that the data carried over their networks is protected against theft and manipulation. For Nokia, the challenge is to deliver a foundation that gives our customers the support they need to help overcome the challenges we all face. To do that, this foundation needs to provide the agility to deal with the unexpected, the efficiency and innovation needed to help address climate change, and the advanced network security capabilities that will help organizations move forward safe from network threats. Today, our expertise and technologies are building the world's most critical IP networks. And now, we aim to help our customers master the unexpected through the delivery of 3 foundational elements in their mission-critical IP networks. These are software excellence, automation and tools, and silicon and systems. The stability of SROS is proven in more than 1 million routers deployed in critical networks worldwide. However, we must continue to evolve to meet our customer requirements, and today, the name of the game is agility. From the beginning of our program, in the early 2000s, we have linked scalable R&D and quality to automation. Today, with tens of thousands of systems in our labs, we can scale development and testing dramatically because of the foresight of introducing automation. We're now taking another step into agility with the introduction of a microservices architecture. With microservices, you can upgrade your applications faster, introduce new functionality, and adapt to your customers' rapidly changing needs without downtime. As we build our network automation tools, we envision 2 types of activities. First, there are macro mutations to the network. These are new services that require human thought and invention. We believe it's possible to create models for these services in a higher language construct. This construct can then be transpiled into code for running the network, that is, the actual configuration of a set of nodes that implement the service. Next, we look to templatize it, to reuse it without error, with contextual parameters that can be automatically introduced into a specific instantiation. In other words, we can move rapidly from concept to implementation through a design model known as infrastructure as code. The second type of activity is micro-mutations, the daily monitoring and tweaking of the network to ensure the runtime behavior of the services are compatible with what has been promised. Given enough of these services and the stringent requirements for performance and reliability that are often mandatory, these micro-mutations to the network must be carried out autonomously by the network management tools. NSP, our network services platform, has been introducing some of these concepts already with intent-driven models, and we continue our investigation into machine learning as a means of steering the network through the daily journey of delivering nonstop services. Nokia is also leading the field in utilizing analytics to derive a security model for the network. We already provide line rate multi-level encryption at the network processor level to secure the IP network infrastructure and its connections. We're now developing in Deep Field Defender the capability to program the network processor to drop packets that are recognizable as threats and to redirect only a small fraction of traffic to quarantine centers where it can be scrubbed. Network transformation programs, such as those to introduce IP platforms, are often complex, multi-year projects carrying significant risk, and here automation can again help. Our professional services team invests in the automation of network transformation to help customers reduce risk, mitigate human error, accelerate deployment, and increase return on investment in the areas of design, configuration, deployment, acceptance testing, and migration. Our IP portfolio features products based on our own silicon design, as well as products based on merchant silicon and cloud environments. For the most challenging applications, our IP routers use our in-house developed FP silicon. A highly programmable processor gives us the ability to pivot as the market needs, from MPLS to layer 2 EVPNs, from segment routing to 5G backhaul networks. We have demonstrated we can repurpose the same hardware to numerous use cases with no compromise to performance or function. Beyond the silicon itself, Nokia has prided itself on the longevity of our systems. Every chassis is designed for efficiency of cooling and power consumption. From using next-generation I/O cards in an older chassis to reusable common cards, from the airflow to the locking mechanisms for line cards, there's an enduring principle that we employ. These systems should have a running life of over 10 years. With the FP5, we're confirming that we remain focused on delivering innovative core technologies that enable our service provider customers to rest assured that they have the right foundation for the future. This includes addressing the challenges we know, including the need to deliver more bandwidth, more efficiently, for more increasingly complex and demanding network services, and the challenges we can't predict, by having the platform and software agility and automation to be able to adjust to anything that may come our way. Our ambition is to be the world's most trusted systems partner for the world's most critical IP networks. This drives our intent, defines the problems we choose to solve, and describes the uncompromising attitude and perseverance of our engineers who develop and deliver projects. Without a crystal ball, we cannot tell you what unexpected events are around the corner. But we can promise that with Nokia as a partner, you'll be in a much better position to master the unexpected.